Okay. This NRI professional RC tester. I thought I was done with it. And it turns out maybe not. It's still working. There's nothing wrong with it. But there have been a number of people who have asked for schematics of this. I would love to have one. I've not been able to find one, at least that I didn't have to purchase. It may be available, and I've already put out notice on one or a couple of my vids that if you find a schematic for this, post it so we can share it. I could map it out, just don't have time. I have a pretty good idea how this thing works anyway. It's not critical. It's not very complicated an instrument. But there was at least one viewer that was asking about the capacitor values. Apparently it's possible that somebody had already worked on it and it wasn't clear if the values that they put in matched factory. And even if they did, sometimes it's difficult to read the markings on them, depending on who did the work and when. So I'm going to go over this. There are not that many capacitors in this thing. There are only a couple, well actually one if you think about it. I'll get into that in a second. The actual absolute value matters. Most of them it doesn't. You get, geez whiz, you probably get in 30% of the stated value. It's going to work. But for this here, this originally had two beeswax capacitors. These are now, they're still present obviously, but they've been cut out of circuit and they've been replaced by these modern plastic capacitors. Each one of these beeswax ones was 1.0 microfarad, rated at 200 volts. They are, in this instrument, they are wired in parallel. So what they were after was a 2.0 microfarad capacitor rated at 200 volts. I don't think, I have not measured it, but I don't think these things ever saw 200 volts because of where they are in the bridge leg. Don't take that as gospel. And nevertheless, what I ended up with, what's operating now, are two 1.0 microfarad plastic capacitors. These ones happen to be rated 10% tolerance. Close enough. Don't worry about it. It's not going to matter a whole lot, but you want high quality capacitors here. Probably want 100 volt rated. You want to use plastic. Don't even think about using an electrolytic in this spot. Use plastic ones, modern plastic ones. So you want 2 microfarad here, and this happens to be, as factory, split between two 1.0 microfarad caps, 600 volts DC rated. Those will outlive me in this application. There are only really 3 capacitors on top of chassis. Let me look, make sure. Yeah, thank you. Yeah, pardon me. There's 3 capacitors on top chassis in this model, this generation of this model. These 2. There might be some where there's only 1 capacitor down in there, where I just showed. If it is, it will be a 2.0 microfarad capacitor. I think I have seen permutations, or at least pictures of permutations of this model where that was the case. You will have to check me on that. Pardon me. Another cap in here. It's not critical of the absolute value. this one, and this has to do with the leakage test function of this beast. That wants to be rated at 600 volts. Don't put a 400 in there. The reason being is because it can actually see that across it. Because this leakage test power supply, adjustable front panel control, goes over 600 volts. This needs to be a 600 volt capacitor. The value here is 0.1 microfarad. It's not critical. You could probably get away just fine with a 0.05 in there. But the factory, what they had in there was a 0.1 microfarad cap. I stuck this orange drop in there. It's a plus or minus 10% tolerance. It doesn't matter. That'll just, the value of this will affect the blink rate of your leakage indicator neon lamp. If it's a lower value, it'll blink more quickly. A higher value will blink more slowly. Put what in they had. Factory was 0.1 microfarad. But the voltage on this guy, you've got to make sure it's 600 volts DC rated or better. I've seen some discussion about this resistor here. This is a 7.5K resistor. That's the one that's used to bleed off when you're doing a leakage test. It does put a high voltage across that capacitor, and this toggle here in the center position is discharge, and pretty much what that does is it disconnects the capacitor you're testing from the power supply and puts across that capacitor this resistor. Judging by this size, this is a 5-watt resistor. The value is not critical. It's interesting they chose 7.5K, 7,500 ohms, and it's a 5% resistor. This is actually a wire wound resistor, by the by. If for some reason you got to replace this, just go with a 5-watt flame-proof resistor, somewhere around 7,500 ohms. It's not critical. Don't go too low with it, because you risk sorting your wafer switch here that connects this resistor across that capacitor. The idea was to limit the current, at the same time maximize or limit the current, and also limit the time it takes to discharge the capacitor, so you didn't unplug your capacitor you just finished doing a leakage test and zap the crap out of yourself, by my reckoning. So that's what's on top. Down the bottom, let me double check. I think that'll do. These guys down here, originally was in here was a tubular electrolytic capacitor, actually a dual electrolytic capacitor, 2 capacitors in one package, and that was totally gone. It's dried out. I just happen to have these handy, used, old stock. These are the original capacitor. The electrolytic in here was 2 4 microfarad capacitors. I don't remember the exact voltage rating. I think it was 250. Look at previous videos on this. I may have mentioned it. Doesn't matter. These ones are rated at 250 volts AC, so they're 500 volt capacitors, DC, which they will never see here. These are also 10 microfarad each. Again, the original was 4 microfarad caps in there. They just supply DC supply filtering. I put 10s in here. Each one of these is 10. Use what you got. I would recommend plastic ones. They'll last a long time. These are not polarized. You do have to be careful of the polarization. In this case, let's see, the this end of these two are two positive leads, and they're tan wires. They may have at once, and maybe at some time, been sort of reddish, but down at the bottom of these is the common, or ground negative connection, which is a black wire that connect common to both of these two capacitors. So here's what you got. Handy are 4.7 microfarad electrolytics, and they're little tiny things like that size, able to withstand that voltage. And the rest of these orange drops in these positions, these three, they are all the same thing. What is it? 0.01 microfarad capacitors. These happen to be rated 600 volts. You don't need 600 volt caps in this beast. If you got something rated 200 or above, it'll work. There's not very high voltage associated with any of these. I use these because that's what I had handy at the proper value, and that's what was factory, 0.01 microfarad caps for these three positions. And of course these replace these little wax paper, beeswax and paper capacitors. There's one here, this one, a similar construction to these orange drops, a dipped mylar assembly. This one is a 0.001, also at 600 volts. Again, that does not need to be rated, that voltage. These days they're so small, and and ubiquitous. You'll find them, and they're cheap. But this one, 0.001 microfarad cap. This one actually connects to the red positive terminal of the capacitor resistor test jack. Again, I don't have a schematic for this. I'm not exactly sure why that's there and what it does, but that's what that was. There was a wax paper capacitor in here, and of that value, and that's what I replaced. I just shotgunned. I did not test them until after I got this thing working again, and actually tested those capacitors using this, and they were all shot. They were bad. Surprising the thing worked at all, but it did, with some creepiness about it, but it did work. So I mean, that covers what the capacitors are in this thing. The resistors, well, it's easy to test those if you got an ohm meter. I did replace a couple in here that were out spec. Previous video, I think it was this one and this one down here. They put some pretty crappy resistors and things back in these days. The ones I put in are used old stock, but they're Allen Bradley's, the best. For the carbon composition resistors. I did put, as I mentioned, I was going to a line fuse in here. This is a 1 amp fast blow fuse. Its only purpose is if something goes wrong, it doesn't cause smoke and fire. Just blows the fuse, and then it just won't turn on anymore, and I got to get in there and find out what happened. This thing will never draw more than 1 amp if it's working right. So anyway, I don't know if there's anything else I can do here to elaborate. I don't know. I think I've got it covered. Folks, please do let me know if that's not the case, and I want to see these. I want to see these working, and more like them working for us graybeards. That's it.